have another example I would like to do with number 29. It's not a whole lot different than the previous example that we just did, but what I would just like to have you see is there's a small difference when we have this radical in it. So I see right here this x squared underneath the radical is the highest power that I have. So what I am going to do is I'm going to go ahead and multiply this bottom by 1 over x squared square rooted, because then I can distribute this all to everything that's underneath that radical. Because remember, if you had something like this, the square root of 3 times the square root of 3, you could go ahead and just look at that as all together underneath the same radical. That's what we're going to do here. So keep in mind, once I do that to the bottom, I must also do that to the top. Alright, and here's the thing. When I do actually simplify the square root of 1 over x squared, what I get is the square root of 1 over the square root of x squared. So what I do get is 1 over x. Thus I can go and look into this as, alright, the limit as x approaches infinity of, and then I'm just going to simply divide everything on top by x. So we have 2x divided by just simply the square root of x squared, so just x plus 1 over x, all over, and then down below here I have x squared divided by x squared, and then minus x over x squared, because I can go and take that 1 over x squared and distribute it to everything underneath that radical. So now I have the limit as x approaches. Alright, and here's now where that your property of 5.5 comes into play, because what that is all equal to is, understand this and this right here, when we're taking the limit towards infinity, those go towards 0. So I have 2 over the square root of 1 plus 0, so just 1, and then what I get here is 2 over 1, so I have the limit of 2. Now, we're done with number 29 and what it asks us, but I want to go with this a little bit further, because you might come across a problem like this where it's asking you to find the limit when x is approaching negative infinity. So we're going to do this very same problem, except for we're going to be finding the left-hand behavior. So technically what this was we just found our right-hand behavior. And what I'm going to do now is I'm going to find the left-end behavior, the left-hand end behavior, and EB, I'm just going to call it. So we're going to be looking at basically the limit of this same function as x approaches negative infinity. And there's just one slight difference in this that I'm going to bring up. And your book approaches this a little bit different than I do, so I just want you to pick which one you want, but you can choose how the book does it, or you can choose how I do it. But we're going to still observe that, yeah, I'm going to want to divide this by the highest power on the denominator, so it's going to be the square root of x squared that we want to divide by. And so what I am going to ultimately do is multiply by the reciprocal of that instead, and we're going to get this right there. So what I have to do is I also have to do that on the top. But here's the thing. What we're doing now is when x is approaching negative infinity, I hope back here when I was doing this problem earlier that when I simplified this, I hope some of you were thinking, oh, but hey, the square root of 1 over x squared would be equal to plus minus 1 over x. Right? I hope some of you were thinking that, and I did kind of ignore it because we were just looking at the positive values, because we were approaching x as we were getting larger and larger in positive values. So now, if you ever come across a limit with a radical and you're going towards a negative value, what I do want you to interpret as is the square root of 1 over x squared in this case. We're going to just use the negative value since we are approaching the negative infinity values, the negative infinite values. So we're going to be looking at 1 over. Okay. So therefore, on this top, instead of dividing by this on the, I'm going to keep that on the bottom. It's going to be a little bit strange, but I am going to divide by 1 over, or I am going to multiply, by negative 1 over x on the top. So what happens is we're finding the limit as that approaches negative infinity, and what we're going to get is 2x divided by 1x plus, and this all equals the limit of, so it's going to be negative 2, because those cancel out, plus negative 1x, 1 over x, all over, and then the square root of 1 minus 1 over x. So once again, it's this right here that goes towards 0, and this right there that's going to go towards 0 as we start achieving negative infinity, because negative infinity or positive infinity, it doesn't matter. What we're going to get here is a 0, so negative 2 plus 0 all over the square root of 1 plus 0. So here we just get negative 2. Alright, so this is the left end behavior, one of our asymptotes, and here was the other one. Okay, so once again, this was only asking you to complete this portion of what I've done all up in here, but I just wanted to let you know what else was going on with these.